Good morning to everyone. Welcome again to this 1 week FDP on scientific language. Today, we have a session by Dr. Jonali Gogoi. The session is on introduction of R. But before starting this session, let me introduce Jonali Gogoi, Dr. Jonali Gogoi with you. Currently, Jonali Gogoi is working as an assistant professor at Assam University. Dr. Gogoi has did her PhD from Tezpur University on the topic of reliability. Two students is working under her. Two PhD student is currently working under her. And Dr. Gogoi has published more than 20 research publications, research paper in different reputed journals. And being an expert of R and SPSS, Dr. Gogoi has delivered lots of lectures in various national and international institutes. As an example, currently, Dr. Gogoi has delivered a talk on SPSS at Shah Jalal University of Science and Technology, Bangladesh. We are very glad to have you among us, ma'am. So now, currently, now I'm inviting Dr. Gogoi to start her talk. Please, ma'am.
Thank you, Dr. Dimple. Am I audible to you?
Yeah, yes.
Okay, thank you. Professor P.K. Mishra, Vice Chancellor, the Talukdar Madam, raised Department of Mathematics Development Program on Scientific Language. Participant phrase. So, Dimple Jyoti Mahanta, number of participants gathering here. So, lots of participants present. So I have seen a huge number of participants in this faculty development program. So I hope all the participants benefited from this well-organized faculty development program on scientific language. So I wish this faculty development program a grand success. So few days back, Dr. Dimple told me to give a lecture on basics on R programming language. So keeping on mind, I have prepared this PowerPoint presentation for those who do not know anything about R programming language. So we can say simply, this is only for the beginners. And the main objective of my presentation is to apprise the participants with some basic knowledge on R. So I welcome all the participant friends to my session. So let's start. The title of my presentation is Introduction to R. This is my first lecture in this FDP, and another one is tomorrow. So that one is on the basis of graphical representation. So first one, this one is Introduction to R. So what is R? We can say R is a freely available software. That is, this one is open source. Okay, this one is easily available for all of us. So this was developed in 1993 by Robert Gentleman and Ross Ihaka. So why we are using R? We are using R software, R programming language to handle large data sets, to be reproducible, and to create more detailed visualization. So here you see, I'm writing some points what is R, how we can explain. So R is data analysis software, which is used by analysts, statisticians, data scientists, and others. And this is a programming language which is used for data manipulation, statistical computing, graphics display, and data analysis. So this programming language was named as R, which is based on the first letter of first name of the two R authors. That means Robert Gentleman and Ross Ihaka. So with this first name, Robert and Ross, this programming language is named as R. So multiple data sets we can open at the same time in this R window. And here, simple as well as complicated calculations we can do. And this R language is very similar to S language, which is based on a software, we can say S+. So this is offered as open source, I have already mentioned. And many statistical packages which are freely available in this programming language. So 6,000 packages on CRAN. CRAN means we can say the comprehensive R archive network. So 6,000 packages on CRAN spread across various domains of study. So we are getting this type of packages here, freely available. And then commands can be saved, run, and stored in script files. I am showing you later what is this script files. And built-in and contributed packages are available in this programming language. Okay, so here remarks I have written here. Press the up arrow key. So what is up arrow key? This is left, right, top, and bottom. This type of arrows are in our present in our keyboard. So this up arrow key we use to recall commands, and we can edit them. That means what? Just I'm showing you here. I have already installed this R. So just I am showing here. This here you see this up arrow key to recall commands. That means here you see I'm writing here 4 plus 3. This is equal to what? We are getting the result 4 plus 3 equal to 7. Similarly, 6 plus 2. This is equal to what? 14. Okay. So if we are using what I'm writing here, up arrow key. So if we are pressing this up arrow from our keyboard, then we'll getting this result. Suppose we've forgot to write here 6 plus 2, then plus 3. But I forgot to write here plus 3. In that case, what we'll do here, just you give up arrow, press up arrow key, and then it will come 6 plus 2. Then you add here your 3. Okay, then you will get the result. So similarly, we can get here also again, if we press this up arrow key, then 4 plus 3. Here, suppose we forgot to add something here, plus suppose 7, then we can add 7. So this is the result. So this is the use of our, that means we can edit them. Here you see, I'm writing here, recall the commands and edit them. So this is the process, and we are using this up arrow key. So now again you see, use the escape key to cancel a command. So here in this case, if we use this escape key, then we can, what we can do with the help of this escape key, we can cancel the command. So this is about your up arrow key and escape key. Dimple, is it again slideshow mode?
Yeah.
Okay, thank you. So next, installing R. So how we can install R? This is I'm telling already. I told that this is for those who don't know anything about R. So I'm showing here from the beginning. So how we can install R in our window. So you may install R in a window by downloading from this website. So https then www.rproject.org. Just you type these things, then what we'll get, this window will come. So the R project for statistical company, it is written like this. I am already downloaded earlier. So this is R version 3.4.3, but now it is, I think, 4.3.0. Okay, so here you see I have given one red color up arrow key here. This one you see. So here it is written download R. Just click on it. I think all of you have seen these things. This up arrow key, red color, which is in red color. And here it is written download R. So just click on this download R. Then what will come? This installing R. So any mirror and click on the link. So this window will come. And then here you see from this O cloud here, you see this is cloud rproject.org, then cloud rproject.org. It is coming. And this time only one thing it is coming here, I have seen. So just you click on it, and then again you will get this type of, I told you about CRAN, this comprehensive R archive network. So how we can install R? Just you type this website and then click here, download R, and then just you click on this, then you will get this type of window. And here you see download R for Windows. Here one left arrow key is here. So download R for Linux, then download R for Mac, download R for Windows is here. So now you click on this, which one you needed. So download R for Windows. Then you will get your R console. Okay, then you will you are able to install your R console. And then what we'll do, like this type of icon. This type of icon you see at the bottom here, this type of icon. Then you double click on it, then it will open. Okay. So this is about installing R programming language in your laptop or desktop. So now these are the objectives which I have chosen for this presentation. Starting with R. Second one is your getting help in R. Then demonstration of R functions, how to quit R, libraries in R, installing packages and libraries, then command line and scripts, data editor, basics, and R as a calculator, then how to import data files. Then here I'm adding descriptive statistics. I'm also from statistics background, so I'm here adding some basic calculations on this descriptive statistics and then tabulation. So now you see, starting with R, to start your R window, just double click on this icon. I told this R icon. Then we'll get this type of graphic user interface window. That means GUI window. If we double click on this R icon, then we'll get what? Graphic user interface window screen. Okay, so this type of window is coming, and here you see this one is just, this is like a greater than symbol. That means this is called your command line. You can type anything here in this window. This is, I have taken the screenshot when I have done. So I just paste it here in this presentation. So just you see, if we double click on this R icon, then we'll get this type of graphic user interface windows, GUI window, and then here it will come like this, and then we can write command here in from this line. And now you see, so getting help in R, how? Start R software and click help button. That means what? Just you see, I am here, this is R, and then here, okay, just wait. This one help is here. So just click on it, then you will get all the things, the console, R console, then all the things are here. Okay. And then now you see, demonstration of R functions, how we can demonstrate it. This can be useful for seeing the type of things which R can do. So just you type demo graphics, and then this will come. This is from our R window, means our console window. Just you see, if we write this demographics, this one is in red color. You see demographics. If we write here in command line, then it will come like this, and then in right hand side it will come this type of diagrams. Now you see how we can show. Just you type here demo within bracket graphics. Just give enter, it will come like this. To type return to start, it is coming like this. Then again you press enter, then again press enter, then this one will come. Again you here you see click or hit enter for next page. That means you just click on enter, then you will get this type of diagram. I think all of you can see from here. This one you see. Okay, this type of things are coming. That means the graphical way. If we write here demographics, then it will like this. Okay, wait, something what will happen. Okay. It's not okay. It's okay. Then you see how to quit R. Just type Q, then bracket to quit R. So here from here you see this one. Hello, Dimple. Hello.
Oh, Jonali, yes.
It is visible or not?
Yes, this is visible.
Okay, okay. Some problem is. Okay. Now you see how to quit R for this. Just type Q, then bracket, enter, then we can quit from R. Okay. The next one is libraries in R. So what is libraries? In a college or university, lots of books are there in libraries. Libraries are also there. So what is there in our library? Functions and data sets are organized into libraries in this R programming language. So to use this library, simply what we have to do, type library function. That means what? Just you see, just you type library, then within brackets. Okay, brackets, that means dot. I am writing here dot. So what does it mean, dots? That means which function you needed. So just you type within the bracket. First you type library, and then within the bracket just you type the which function you needed. Okay, so just here for example I have taken spatial. Okay, so this spatial we type here in place of dot. So library within bracket spatial. So this is the libraries in R programming language. So now you see what are the contents of libraries. This one is easy to use, the help function. That means what type of function we needed, just you type library, and then you take the help function here, and then you write special. Okay, that means to find the content of the special library. That means what is there in special in this library. So what are the contents are available there. So just you write here, just type library, and then within the bracket you write help equal to special. So what will come, just you see, this type of window is coming. Here I am writing in R console library, the within the bracket help, this is equal to your special. Is it okay? So if we write library within the bracket help equal to special, then it will come what? This type of window. Okay, what is needed? So this is coming here. And then again you see this is the package special, then priority is here, version, what type of version is, then what is the date, and then all descriptions are here. So this is in case of our library in R, libraries in R. So just only one example I have taken here to show you just how we can find out the contents of in our library in R programming language. Just I have given this example, library special. Then installing this R, just you see to install any installing packages, how we can install this package. You see, just run the R program, then on the command line use the install packages. That means you have to write in command line. I am going to show you in just command line you write install.packages, then this function to download the libraries which we want. That means which packages we needed, then these packages will come if we write install.packages. Okay, so for example here you see, just I have taken two, R meta and agreement. So R meta is, this is useful for us, for statisticians. That means R meta contains the statistical tools for meta analysis. Okay, so that's why I'm just only taking these two example, R meta and then agreement. So now you see what is agreement. Agreement contains the statistical tools for measuring agreement. Okay, so just to install these two packages, how we can write, how we can type in our command line, just you write install.packages, install.packages, within the bracket, within inverted comma, you write R meta. And for the same agreement, for in case of agreement, just you write here, type here install.packages, then within the bracket agreement. Okay, so this is how to install packages in R. Okay, so just you write install.packages, within the bracket which function we need. Then you see command line and script file. So what is command line? I have already told what is command line. I have already shown to you. This is the command line. Here I think all of you have seen here one left arrow symbol is there with red color. So this one is called your command line. Just you see, this is our R console. This one is your, this one is your, this one is called command line. Command line. Okay, and now you see what is there, command line and then script file. Okay, what is this? Script is what? Script is accessible from our RGUI menu bar. That means just you click on file, just you click on here. I think all of you have seen file, and then here you see new script. Okay, so just click on this, then this will come. This is your script file. We can save all these things here in this script files. Okay, so here it is given, this file. Just click on file, then left arrow key here, new script, just click on this, then you will get your script file. Then data editor. So now you see what is this? File, then a new script. So this one is coming. So I have already shown. Next, basics in R as a calculator. So what is this? Just you see what symbol is here. This is greater than type. We know this type of symbol is called greater than type. Another one is left hand side. Okay, this one is called left hand side. This one is less than type. Okay, so this one is greater than type. Now you see basics and R as a calculator. So this greater than type is the prompt sign in R. Okay. And the assignment operators are the left arrow with dash. Left arrow with dash, that means this one is, you see, less than and then dash and equal sign. This is, you can say this is, we know this is equal sign. This x less than dash 50. What is this? What is the meaning of this x less than dash 50? This assigns the value 50 to x. This assigns the value 50 to x. Okay. And then x equal to 50. What does it mean? This assigns the value 50 to x. But what is the difference between equal sign and less than dash in this R programming language? So what we can say, in this R programming language, the operator less than dash, this can be used anywhere. But whereas the operator, this equal sign, is only allowed at the top level. For example, what we can say, in the complete expression typed at the command prompt. Okay, so this is the difference between this less than dash and then equal. So here, this less than dash was available in R. So now, okay, so basics and R as a calculator is continued here. The basics you see, this is, I have already told, x, this is equal to 50. This assigns the value 50 to x. Y equal to x star 2. That means this is the product. Here in case of R language, we write x star 2. So this assigns the value 2 star x to y. And z equal to x star, x plus y, this assigns the value x plus y to z. Okay, so this is from R console. I have pasted here. Just to see, x then less than dash 50. Then again you click or hit on enter, then write x. Then this will 50. X equal to 50, then x, again you write just enter, then 50. Y equal to x star 2, then y, this is equal to 100. That means what? Just you see what we'll do. What happened? This one. Okay. So how we can do these things? Just you see, x equal to 50, then just press enter. Then again you write x. Okay. So what is writing here? It is already in this slide. Here x less than dash 50x, or if we write x equal to, the meaning is here same, x equal, that means the x variable takes the values 50. So this is x equal to 50. Then again if we write x, then what we'll get? This is equal to 50. Now you see here, then enter again, then x equal to 50. Okay, so next one is what? Y equal to x star 2. So you write here y equal to x, then star 2, then give enter, then you write again y 100. That means, what is this? X equal to 50. Already here we know x equal to 50, x takes the values 50. And what is y? The value of x is 50, then this is 2. That means what? The result is 100. So this one is here, x equal to 50, then y equal to what? X star 2, this is equal to 100. Then what is z? Just you add x and y. So what is x? X is 50. And what is your y? Here, just you see, what is your y here? Y is your 100. So z equal to, z is what? X plus y. So x plus y is equal to 50 plus 100. This is equal to 150. I think up to this all of you are clear. Then again you see, this is hash. This symbols marks the beginning of a comment. That means what? All the characters until the end of the line are ignored. That means you see, SD is called in statistics, this is the standard deviation. X less than dash 50 is treated as comment only. Okay, that means what you see. This is the R console window. I have pasted here. If we write in that window, X equal to 50, then Y. So here you see error. It is written here error. Object Y not found. That means what? Here we are writing only X equal to 50. So how can Y give the value? Because here the variable name is X and here we are writing Y. So that's why it is given error. Because Y is not known. Only we know the value of X. X equal to 50. Y is not known. So this is the error, object Y not found. So Y is not there. Now you see again, here has, then Y equal to 50. So this is equal, then the next command line, just after writing this, just enter and then you write Y. Then what is coming here? Again, error, object Y not found. Why object Y not found? Because here I am writing this symbol, this symbols marks the beginning of a comment. Beginning of a comment, that means this treated as comment only. So that's why it is not able to take the values of Y equal to 50. So if we write Y equal to 50, then Y, then we'll get 50. Only we can write like this. If we give this symbol in front of Y, then this will come as error. That means we are not found. R is not able to find out the value of Y. Okay. The next you see, small letters and capital letters are different. Okay, so X less than dash 50 and X less than dash 50 are different. That means what you see here, I am writing first as X is your small letter, is in small letter, and you see the second one, second X variable I am written here is in capital letters. So small letters and capital letters both are different and are not able to, our programming not able to read this. Okay, so if we write here X equal to small x equal to 50 and after giving enter, after clicking on enter, then hit the enter, then what will get? Capital, if we write again capital X, then here again error. Error will come because this is not capital X. Here this one is capital X and this one is small x. R is not able to read this capital X here. So object capital X not found. Means we are giving here only the values of X, the small x equal to 50. And if you write capital X equal to 50, then again you write capital X, this capital X, then this one is what? This one is your 50. That means we R can read this one. Capital X equal to 50 and then capital X, this one is the value of X is your 50. And similarly, we can write if small x equal to 50, then here you type in command line small x, then we'll get the value of small x is 50. Next, you see the command C. C for, what does it mean? This C? C for combines the numbers. Okay. So C 1, 2, 3, 4, 5, 6, 7. These are the simple examples I have taken here for you. So the command C 1, 2, 3, 4, 5, 6, 7. This combines the numbers 1, 2, 3, then to a vector. That means what? Just you see, this is from R console, R window. Y equal to Y takes the values 1, 2, up to 7. Okay, 1, 2, 3, 4, 5, 6, 7. Just you put enter, then just you see. y equal to 1, 2, 3, 4, 5, 6, 7. Just give enter, then it will come error, unexpected. That means what does it mean? You see, y equal to 1. This look like as y equal to 1, 2, 3, 4, 5, 6, 7. 1, this is y equal to 1. Not y takes the values 1, 2, 3 up to 7. In this R language, so here what we'll do, y within the bracket 1 to up to 7, then again error will come. Okay, what does it mean? Y equal to only 1 within the bracket, then comma. Okay, then the others value 2 to up to 7. That means if we write again y equal to within the bracket the values 1, 2, then okay, this will again error. And then you see error in what? Error in what? Just y equal to 1, then again you stop here, then 2, 3, like this. So the understanding of R in these two cases are same. If we write like this, y equal to c, that means the combine all the vectors 1 to up to 7, then it will come like this. Just you write y, this is equal to c within the bracket 1, 7 up to 7, then give enter. Then again you write y, then enter. These are the values. That means y takes the values 1, 2, 3, 4, 5, 6, 7. So these are the simple things to know. And then R as a calculator. So what is R as a calculator? Just you see. 4 plus 2, this is common 6. 6 is your output. That means what? This is the R console window. This is only in our slide. So 4 plus 2, if we write this command in our R window, R console window, 4 plus 2, this is equal to 6. Then here you see this is called command, then output. This is also command, this is output. This is command, this is output, like this. So 4 minus 2, this is equal to 2. 3 star 2 means 6. 4 divided by 2, this is equal to 2. 3 cap 2. 3 cap 2, that means what? 3 square. Okay. This is the product. This is 3 to the power. 3 to the power, that means. So 3 cap 2, this is equal to your 9. 3 star 2, that means this is same. This is 9. 3 star 2, this is equal to 9. So this is, we can say, these are the basics things about R as a calculator. Now you see 3 star 2 minus 4 plus 2 divided by 6. So here you see in our console.
Hello, madam.
3.
Hello,
Yes.
madam.
Hello.
Madam, can it take cube roots?
Can what?
Cube roots, madam.
Yeah, we can write.
Okay,
Only the simple things I have given here. So I will come later.
okay, thank you.
So 3 star 2 minus 4 plus 2, then divided by 6. Just you see here 2.3 point. That means the product, this one is product. Then this one is from 0.5. This is the result. And then C1, 2, 3, 4, then cap 2. That means combine these things. That means what you see, 1 cap 2. That means 1, 2 cap 2. This is your 2 cap 2. This is your 4. 3 cap 2. This is 9. 4 cap 2. This is 16. 4 square. This is 16. 3 square. This is 9. 2 square. This is 4. 1 square. This is 1. So similarly, this is only for one value. Here we are considering only 2. And here you see in this example, 2, 3. That means what we'll get here. Just you see here 1, This is what? 8. That means 2 cube equal to 8. Then 3 square equal to 9. And 4 cube equal to your 64. Okay, this is the result. So 1, 8, 9, then 6, 4. This will come like this. Now you see. Okay, addition and subtraction. Here you see x plus y, x minus y. Now you see, that means these two variables I have taken. So C means combines 2, 4, 6, 8 plus 5. So this is the result. 2 plus 5. This is equal to 7. So here this is our console. 2 plus 5, 7. 4 plus 5, 9. Then 6 plus 5, 11. 8 plus 5, this is 13. Then again, if we have taken, see, combine this 2, 4, 6, 8 vectors, then the values, then C minus 2, minus 4, 6, then minus 8. So this is 0, 0, 12, 0. That means what you see, 2 plus 5, 4 plus 5, 6 plus 5, 8 plus 5, this here I have written. And for this case, 2 plus 2, that means 2 plus minus 2, 4 plus minus 4, 6 plus 6, then 8 plus minus 8. So this is the result. Then multiplication, here you see multiplication and division, x star y, then x divided by y. So what is this? C combines the values 1, 2, 3, 4, then star 2. So 1 into 2, 1 star 2, 2 star 2, 3 star 2, 4 star 2. So these are the results, 2, 4, 6, 8. So here you see 2, 4, 6, 8. And then again for the second one, C within the bracket 1, 2 up to 4. Then here C, that means this is the product, C minus 1, minus 3, minus 4, 6. Then we'll get this result. And then again, C means combines 2, 4, 6, 8 divided by 2. Here you see 2 divided by 2, 4 divided by 2, 6 divided by 2, 8 divided by 2. Then similarly for this one, 2 divided by 2, 6 divided by 3, 4 divided by 2, and then 9 divided by 3. It will take like this in our language. Then integer division, just you see percentage divided by percentage. So what is this? Division in which the fractional part, that is the remainder is discarded. Now you see this, for this example, C 4, 6, 9, 13, and then here you see 4 and 6. So just you see 4 divided 4, this is 1, 6 divided by 6, this is 1, 9 divided by 4, that means 4 into 2 equal to 8, and our remainder is 1. So only we have considered here 2. In this programming language, only consider this 2. And then again for 13 divided by 6, this is 2.
Ma'am.
Yes.
Can we let the 3 elements in the second combination when C is 4 and 6? Here we use 3 elements like
Here
4, 6, and 2.
Sorry, means your question is C means the first value we have considered here 4, and here is 2. Yes.
Yeah.
Can we do three values here?
Yes.
Yes. Here I am just taking only simple examples, nothing else.
Okay. Thank you.
So
Hello?
modular division, just you see
Ma'am?
x mod y. This is, yes. Hello.
Yes, ma'am. Please continue.
Okay. X mod y. Here you see modulo operation finds the remainder after division of one number by another. That means here you see 4, 5, 6, 9. Then divided this modulo, sorry, not divided. Percentages symbol is here. Then 4. So what is the result? What is the result here? You see 4, then percentage symbols are there, then 4. This is equal to what?
Remainder.
Yeah. That means what we do, x mod y is what? Only modular operation finds the remainder after division of one number by another. That means here 4 by 4 is what? 1 means 4 divided by 4 is 1 and remainder is 0. So here it is only 0. And 5 divided by 4, this is 4 1 ja 4, then remainder is your 1. So only we can write here only the 1. And 6 divided by 4, that means what? This is 2. Okay, remainder is 2. And for this case, remainder is your 1. So this is your x mod y. This is the R console I have given. Some built-in functions in R. Okay, these are already there in R. So maximum, it is written as max, M-A-X, and minimum, this is M-I-N. So maximum, just you see 1, then 0.2, 3.5 minus 2.5. So here it is only, what is the result? 3.5 here. From the example, we can see that 3.5 is maximum. So in case of R, just you write maximum, and then within the bracket you write the values, and then hit enter, then you will get the result of maximum. So similarly from here also, what we can do, just you see 3.5, we can write like this. And now you see again, that means what we have done here, maximum of within the bracket the values and maximum of within double bracket we are using here. You see, first bracket is for the combining the values and the second bracket only for using the values. Okay, so in case of minimum, this is same. So you see minimum of 1, this values are there, and from here we can see that the minimum value is minus 3.1. So it is coming. So next, importing data files. Suppose we have some data on our computer and we want to import in our R. So different formats of files can be read in R. So what are these? CSV, TXT, Excel. Okay, so what is CSV? This is called a comma separated values data file. TXT, table file, spreadsheet, MS Excel file, for example, and then files from other software like SPSS, Minitab, etc. And we can import these data files in our R programming language, R language. Okay, but R language does not provide any spreadsheet view of data. Okay, just to remember these things. Now you see importing data files, how we can import this. One can also read or upload the data file from internet site. Okay, so comma separated values data file, how we can do this. At first, set the working directory where the CSV file is located. That means where your CSV file is in your desktop or laptop, just you set the working directory like this. You have to write like this, set WD. That means working directory, set working directory, and within the bracket and inverted comma, you write location of your data set. So where is means the directory or whatever, just you type here. Okay, just I'm writing here only location of your data set. Then to read CSV file, just type read.csv, then within here, suppose file name, what is your file name, then you just give here file name.csv, and here you see data, then dash less than dash read.csv data file.csv. Okay, suppose your file name is data file you have given, then data file.csv. Then CSV data file, you see comma separated values. For example, just I'm giving here one example. Data, I'm writing here data, then less than dash read CSV, Then you see here I'm writing E then dot colon jona1.csv. This is what? This is my file name. Okay. And where this file is in my laptop, this is in this directory. Okay. So I'm writing here E then colon jona1.csv. Okay. This is the now you see data is here x1, x5, x20. That means 1 to up to 5, and then these are the values. Okay, so now you see here A, B, C. I think all of you have seen A, B, C column. Then here you see the values, but here you see in our console only from here 2, 10, 30. From here the values are present. Here you see 6 values and here 5. Here also 5. How and why? I'm telling. Now you see comma separated values data file. If the data file does not have headers in the first row, then we use what? Data then less than dash. For headers, just you see, I'm going to tell you about this. Okay, headers, read.csv. Within bracket, you just write data file.csv, then header equal to false. Header equal to false means if the data file does not have headers. Then it will come like this. You see, here you see 1 to up to 6. All values are there. 5 to up to 30. Here you see in V2, 5 to up to 30, 20 to up to 70. So here I am writing what? Header equal to false. So nothing is there in our data file. So we have to write here header equal to, header equal to false. Then it will come like this. Because in our earlier example, here you see only from 2 to 70 it is coming. Okay, so this is the difference. Then Excel data file, you see the XLSX package has the function read.xlsx. Then within bracket for reading Excel file. So this is, we can read the Excel file. So to read this Excel file, first what we have to do? First, we need to install the package. For this, to read Excel files, first we have to we should install the package. So what is the package for packages for Excel file in R? So install.packages, just you type in command line install.packages, then XLSX. Okay, then you just type library, then within the bracket this XLSX. Then you write data, then less than dash read.xlsx, then within the bracket, what is your data file? Then XLSX, then sheet name. Okay, then we can read, we are able to read the Excel files. So what is txt file? We want to read a text file that contains a table of data. So how we can read? Read.table function is used and it returns a data frame. So what is data frame? I'm going to tell you again later. So first you see read.table, then within the bracket you write the file name. For example, data, then less than dash read.table, then within the bracket you write the data file, name of your data file, then .txt. This is your txt file. And now you see I have saved in notepad. So this is zona 1. I have taken the same example. So here example is C, data, then less than dash read the table. Then this is from E directory. So E, then colon jona1.txt. So this is your txt file. Then SPSS data file. For SPSS data files, use foreign package and function. Just you have to remember some parts of some terms in R. Okay, nothing else but simple calculations you can do from this presentation. I think who don't know anything about R, he or she can able to do something about R. Okay, so read.SPSS, then what we have to do here also in for SPSS data file, again we need to install the packages. So again you write here install.packages in your command line in R console, then within the bracket you write foreign, then again library foreign, then just you write, for example, what data, then this less than dash read.spss, then within the bracket you write here your data file and then dot save. This is your SPSS data file. Okay, so these are the files. Next, in my presentation, I told you this is some descriptive statistics I have considered here. So in today's world, what happened? Understanding of statistics is essential in every field. Like we can say agriculture, business, economics, electronics, biology, medicine, then we can say physics, political science, psychology, sociology, everywhere I think. Okay, so it is needed. So this is why we can say statistics is an important tool even for those who do not use statistical method as part of their job. So frankly speaking, what we use statistics in our day-to-day life. So that's why we shall discuss some basic descriptive statistics here. So these are your measures of central tendency, then measures of dispersion. So these two things I'm going to explain here. So what is measures of central tendency? This includes mean, median, geometric mean, harmonic mean. Mode is also there, but in case of R, mode cannot be computed directly in R. Okay, so that's why I'm not considering here mode. So only mean, median, then geometric mean, harmonic mean. And from dispersion, this includes range, interquartile range, then variance, standard deviation, quartile deviation, and mean deviation. These things are only needed. Maximum of we are using this type of things who are from statistic background or who are not from statistics background. This type of things we are using in our daily routine. Okay, so next, importance of central tendency. What is the importance of central tendency? Why we study, why we find out this mean, median, geometric mean, harmonic mean? To find representative value. Then to make more consensus of data, to make comparisons, and then it will be helpful in further statistical analysis. So these are the importance of our central tendency. And next one, just I'm explaining simply, I'm explaining who don't know about this. So just mean, what is this? Is also called simply mean or arithmetic mean. It is only the sum of all the observations which is divided by the number of observations. And geometric mean, I'm going to give you the this formula. First you see what is this. Geometric mean is what? Geometric mean is the innate. Sorry, this is NTS means this is in innate. Okay, innate root of the product of the varied values. And then what is harmonic mean? It is the reciprocal of arithmetic mean of reciprocal of the varied values. And what is the median? Median is the middlemost value of the variable when the observations are arranged in order of magnitude. That means what? In ascending or descending order of magnitude. Then these are the formulas how we can calculate mean, geometric mean, harmonic mean. So you see mean is x bar equal to 1 by small n summation I goes from 1 to small n xi. This is without frequency. Means suppose if frequencies are there, then the formula will be different. This is 1 by then that time this is 1 by capital N then summation fi xi. Like that, if frequencies are present. So I'm just taking the simple one, x bar equal to when frequencies are not there. So 1 by small n summation over I goes from 1 to small n xi. So what is this in red? Mean x. In red color, I'm writing here in red color mean x. That means this is the formula. This is in case of our this is the formula for our language. Okay. That means we write mean within bracket x, then this will find in our language what is mean of your given data. Then geometric mean, this is x bar, GM is written and this is the geometric mean. Then product of I equal to 1 to up to n xi to the power 1 by n. This is the nth root of their product. Okay, so in our language, how we can write product within the bracket x, then cap within the bracket 1 divided by length of x. Then harmonic mean, x bar, this is equal to small n divided by 1 by n summation I goes from 1 to small n 1 by xi. So this is 1 divided by mean within the bracket 1 divided by x. So this is what? This is the reciprocal of the arithmetic mean of reciprocal of the variate value. So this is the reciprocal of your arithmetic mean. Then what is median? Median is the value such that the number of observation above it is equal to the number of observation below it. So how we can write median within the bracket x. Now you see the example. I am taking this example, simple example I am taking here. Then marks, then combine the values 62 up to 70. Here you see these are the values. So 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. Okay, so these are the values. How we can calculate our arithmetic mean? Just you see marks. Here it is given marks. Okay, so that's why we are writing here marks. Then less than dash C. And you write here, it is not coming. I've just taken only this screenshot. Values are present there. If we write in our console marks, then less than dash, just you write C, then within the bracket you write whole values, all the values you write, and then you write again mean, then within bracket marks. So here you see, here I'm writing mean within bracket x. So here x is our marks. So that's why we are writing here mean within the bracket marks. So this is what is the mean of this example, 57.6. Then geometric mean. So this is we know the how we can write in R. So product within the bracket x, then cap within the bracket 1 divided by length x. Then this is equal to 53.10744. So this is your geometric mean. So this is all the values are present here. I'm not taking the whole screenshot. So again, harmonic mean 1 divided by mean, then within the bracket you write 1 divided by x. Okay, so but here you see 1 divided by mean, then within the bracket 1 divided by, in place of x you just write marks, because in our example it is given marks. If it is given something different, then you write the what is there, then just you write here only those things. Then median. Median within the bracket x, so median within the bracket marks, this is your median 59.5. This is the R console window. Then summary of observations, that means what we have find here, mean, median, then geometric mean, harmonic mean, all those things. So summary of observations mean on the basis of this example, just you write summary within bracket marks. So it will come, this is the minimum value, and this is the maximum value, and this is the first quartile, then this is your mean 57.60. So use the C, what is our mean, what is the value of our mean, 57.6. So this coming here 57.60, then this is third quartile, and this is the value of our median. So this is 59.5. So 59.5. This is the summary of observations we have taken on the basis of this example. I think up to this, all of you have cleared.
Ma'am.
Then you see.
Hello, ma'am.
Yes.
I have one question.
Okay.
Ma'am, if frequency distribution is given, then can we compute this all measures using R?
Yes, yes. I have just here, I have considered only the simple things. The whole thing I have not covered here. The basics things, how we can use in our programming language. So only the basic things I have taken here. Okay.
In that case, how to import?
Yes.
Okay.
Tomorrow we have another class on graphical techniques. So I'll show you there. Means we are considering frequencies also, no problem.
Okay. Okay. Thank you, ma'am.
Okay, now you see
Excuse me, ma'am.
this is
Excuse me,
the
Excuse me.
measures of dispersion. So here the first one is range. So what is range? Now you see it
Excuse
is
me,
a
ma'am.
different.
Excuse me, ma'am.
Yes.
Sorry for disturbance, madam. Nothing. Just can we handle continuous type of data in the R programming, madam? R language.
Can we what? Can we what?
Suppose we have class interval and frequency. Is it possible to find the mean, harmonic mean, etc.? Is it possible?
Mean which type of data you are using?
Continuous data, right? Like class intervals
Yes.
and frequencies.
Yeah. Yes. Yes. Yes.
Yeah, if possible, can you explain that also, ma'am? Thank you.
Okay. Okay. So range, you see, it is the difference between largest, that means the maximum value, and the smallest, that means the minimum value. Okay, so this is called our range. Then interquartile deviation, it is the difference between the third and the first quartile. This is called our interquartile deviation. And standard deviation is what? This is defined as the square root of the arithmetic mean of square of deviations of a set of observations from their arithmetic mean. These are the important tools we needed in statistics. So next one is your variance. This is the square of the standard deviation, which is called your variance. Then quartile deviation is what? This is defined as the half the distance between the third and the first quartile. So this is third and first quartile. This means if we divide the whole set of observations into four equal parts with the help of 3 points, Q1, Q2, Q3. So Q1 is called your first quartile. Q2, this is also called your second quartile. And then Q3 is called your third quartile. So I'm not explaining in these things, just only quartile division is what I've given the formulas also here. So it is defined as the half the distance between the third and the first quartiles. So mean deviation, you see, this is defined as the mean of absolute deviation of a set of observations from its central value. So these are the formula. Range, this is maximum, minimum, maximum within bracket x. For this example, what we have considered earlier, then you write here marks, maximum marks, then minimum marks. Okay, so interquartile range, this is third quartile minus first quartile, IQR, interquartile range within bracket x. Then variance, this is equal to, this is the formula, 1 by small n summation xi minus x bar whole square. Then this is the variance of within the bracket x. Then standard deviation, square root of your variance. Then quartile deviation, IQRX divided by 2. So this is the formula. This is defined as the half the distance between the third and first quartile. So quartile deviation is your IQR divided by 2. Third quartile minus first quartile divided by 2. So interquartile is divided by 2. And what is mean deviation? Mean deviation is your equal to 1 by small n, then summation over I goes from 1 to small n. Then this is the modular sign, xi minus x bar. So sum, you just write for mean deviation sum within the bracket ABS, absolute, that means the within the bracket x minus mean of x, then divided by length of x. These are the formula to write in R. So these are the R command. So with the help of same example, I have written here, with the help of same example means what we have considered marks within the bracket, see within the bracket, the marks 60, 70 like that, all those values, just you see. Range, maximum minus minimum. So here maximum, then within the bracket x, in place of this x, you write marks, then minimum within the bracket marks. So this is 76. So similarly, interquartile range, IQRX, this is 33. So this is IQR within bracket marks. Then similarly the variance, 486.1474, variance of within the bracket marks. Then standard deviation, how we can find out? SQRT, this is within the bracket variance of x. SQRT, R console is here, SQRT variance of within the bracket marks. Then for quartile deviation, IQR, this divided by 2. Just you write in your R console marks within this this command, then you will get this result. Okay, I think all of you can do this. That's why I'm taking all the screenshots here. This presentation will help you to do later. Okay, just you see this presentation and then you can try to practice by yourself. So mean deviation. So this is equal to what? Just you see mean deviation, then sum, then absolute, then within the bracket again marks. That means x minus mean of x. So marks minus mean of marks. Okay, then divided by length of mark. So this is your mean deviation. Then next you see skewness and kurtosis. So we can find also skewness and kurtosis. Lots of calculations we can do in R. So only the basics things I have taken here as an example, because for this time limit I have to complete with these basics things. So that's why I'm not covering all those things. So just only the simple things I have covered here. So skewness and kurtosis. So first, what we have to do to find skewness and kurtosis? First, we need to install a package, moments. So what is this name? This is moments. So install that packages, within the bracket you write moments. Then you type again library within the moments. The procedure is same. Install the packages, then what you need, you just write here moments, type here moments, then library moments. Okay, to find out the skewness and kurtosis. After loading this, then you can you are able to find out the values of skewness and kurtosis. So this is the same example. Now here you see library within the bracket moments. Just you type only library within the bracket moments, then it will work. Okay, in your R console. Then marks within the bracket, just you see the values are there, and then skewness within the bracket marks, and then kurtosis within the bracket marks. Okay, so this is the value for skewness, and this is the value for kurtosis. Okay, 0.09869395. This is your skewness and this is your kurtosis. The next, tabulation. Just you see, this is also important. Data frame, we are using this in case of our matrix calculation. Okay, so what is data frame? You see, a data frame is used for storing data tables. It is a list of vectors of equal length. Okay, so now you see this example. A equal to combine C 246. These are the values. B equal to C, SS, PP, Q, Q. Just I'm taking only the values. N equal to this true, false, true. DF. DF means data frame. This is called data frame. So data dot frame within the bracket, this A, B, N means what is the value. What are the values taken by A? This is 246. Values taken by B, SS, PP, Q, Q. Values taken by N, true, false, true. This is only the example. So what is the data frame? So just you type DF. This is equal to data dot frame within the bracket, this 3 A, B, N. Okay. So we use built-in data. We use built-in data frame in R, which is called our empty cars. Okay, so this is already there. Then now you see, if we write in command line in our console page window, empty cars, this will come like this. Okay, then tabulation, you see, my last objective is your tabulation. So data frame, just you see example, column 1 is taken 57936, column 2 this is taken by these values, and column 3 this is taken by these values. Now you see column 1, column 2, column 3. So what is the data frame? Just you see here how it will come. Data dot frame, column 1, column 2, column 3, column 1, column 2, column 3. Just you see, these are the data. Is it okay? 57936, 57936. And similarly for column 2, 22 up to 60, these values are here. This is like as tabular form. Okay. Suppose we are we are considering the values. Suppose we are considering the values x equal to combine, then within the bracket 1, 2, 3, 4, 5, 6. Up to this I have taken, and then again just you write y equal to some values. You can say also, no problem. Just I'm writing here 9, 8, 7, 6, 1, 2, 3, 4, 5, 6, 4, then 5, then 4. Okay. So you give your bracket, then give enter. So how we can use this data frame df equal to, how we can write this is data data dot frame data frame. Within the bracket you see x comma y. This x comma y, because here we are considering x and y, so that's why we are writing df data dot frame x comma y. Then you hit enter, then again you write df, then again you hit enter, then this will come like a table. Okay, so now you see here, means I have taken here in this example column 1, column 2, column 3. So this is your data frame. Okay, I think all of you have clear. And another one is here, example 2, in case of our data frame, creating contingency table, okay, from vectors. That means data 1, just you see, we are considering 4, 5, 7, 4, like this. Okay, data 1 takes the values, this 4, 5, here our console is here, 4, 5, 4, 5, 7, 4, 3, 8, 6, 3, 5, 2, 4, 1. So this is these are the data. So within here you write table, within bracket you write this data 1. This is here I am writing data 1. If you write this is marks, another anything you write, what you want to write, what is your depending on your data set. Okay, so you write just you just give the name like that, and then you write all the datas, and then it will come. Okay, so table, then within the bracket data 1. So you see this is as like a table. So now you see from here how many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 values are there. And here in this data frame, just you see up to 8. Here you see, in case in this data set, you see 1 is only one time. So that's why here it is 1. 2 here you see 2 is also in one time. So this is 1. 3 for 3, this is 1 3, and another 3 is here, so that's why it is written 2. And then for in case of 4, this is 3 times, 1 2 3, so this is 3. 5, this is 2 times. 6, this is 1 time. 7 1 time. 8 1 time. So like this is with the help of this data set we are preparing this table. This is called your contingency tables from our vectors. So here it is written, here we use the table, this command to organize the data into a simple contingency table. So this table shows how many items. What is the meaning of this table? This is a table. So what is the meaning of this table? This table shows how many items in the data match up to the various integer values. So what I'm telling, so 1 is 1 time, 2 is 1 time, 3 is 2 times, 4 is 3 times, like this. So this table shows what? How many items, how many values in the data match up to the various integer values. So this is your about contingency table, how we can create contingency table from our vectors. Okay, so this is my last topic, last objective for this presentation, today's presentation. So thank you.
Anyone
Hello,
have
Dimple?
any? Yes.
Okay.
Anyone have anything to ask? Any question? Any queries?
Time is okay, Dimple?
Yeah. This is fine. someone is requesting you to kindly share the presentation.
Okay. I'll send it to you.
Or otherwise, you can also send it to the group directly.
WhatsApp group.
Yeah.
Okay, no problem.
So
Okay.
if you have
With
no
the
issue,
help of this
if you-
presentation, they can able to do something about R. Okay, basic things on R. So I'm sharing this presentation in our WhatsApp group. Okay. So thank you.
Anyone have anything, any question? Can we perform permutation and combination calculus? So this is a question from Sonny Gupta. Janeva, can you hear me?
Yes.
Yeah. There is a question from one participant. So can we perform permutation, combination, and calculus in R?
Calculus. Listen, everything we can means maximum of calculations and mathematics from statistics we can do in R. Okay, but I'm not touching these things here. I am also from statistics background. That's why I'm taking here only the descriptive statistics part, because most of the researchers they are using only the statistical calculations.
Yeah,
Okay?
R is basically popular for that only.
Yeah. Basically,
For
R
the
is
statistical
yeah.
tools.
Yes. R is only the means the basically popular for statistical tools. Okay, but maximum of calculations we can do here.
I have seen lots of well-defined functions are also there.
Yes.
Like how easily we can perform those statistical tests here.
Yeah. I am also a learning stage because I'm still I'm learning means how to use R, how to use commands in R, because different books. Okay, I have already shared 2 books in WhatsApp group. I think all of you have seen. Another book for I can recommend. This book is also a very good book for beginners, but I don't have the soft copy. But you can take the name Statistics Using R by Shudha Z. Purohit, Sarat D. Gore, and Shailaja R. Desmukh. Okay, this the second edition of this Statistics Using R. This one is a very good book for beginners for doing analysis purpose. So you can see this book also. And I have already shared 2 books.
Anyone have any kind of question, anything to say? I think no one have any question. Someone like, can you take a practical problem on calculating descriptive statistics? So one question from like some participant.
Where it is coming?
In the chat box, like here, the Zoom only. If some participant want, they can unmute. You can unmute and ask the question directly also.
Can you take a practical problem on calculate? Yes. Yes, we can. I'll give you this question. I think, Dimple, can you take a practical problem on calculating descriptive statistics?
Yes. I'm talking about that only.
Okay. So for this descriptive statistics, I have taken examples in my slides. I have already given. These are the simple examples, basic examples I have given. But you can see, and I'll also provide you means if you need this type of example, then I'll prepare and then send it to your means the coordinator or in our WhatsApp group. No problem. I can share with you this type of problem.
Okay. So
how we can find out all the mean, median, and mode. But I have given here the formulas, means the coding, how we can write in R. So with the help of this, if you got these slides, then you can do it, I think.
anyway, ma'am, we have a like problem solving session on 30th and 1st. So we are putting the problem solving session on
Okay,
our
I will give you the questions for those sessions. I'll give you the questions. You try by yourself, dear participants, you try by yourself. And if you are facing any problem, then you can give messages in our WhatsApp group, no problem.
Okay. So like Dr. Otonu Kumar Srivastav, so can you send a PDF? So ma'am has already shared 2 books. The PDF
Yes,
of
I have
2
already
books.
shared.
This
I have
morning
already shared the
you,
PDF.
you can go to the WhatsApp group. And ma'am has already shared 2 books in the WhatsApp group in the early
2
morning.
books I have already shared.
Okay. I think everyone got your answers, right? So thank you, everyone. So thank you, madam, for this very informative session. So you have taken all the basic things of R from the starting of how to download this software, how to install it, and how to fundamentally how one can use, a new learner can use all the tools of R. You have covered all those things. Thank you for this very informative session. So
Thank you, Dr. Dimple.
and obviously this is not the end of this session, so you are going to continue tomorrow also. So then we'll meet tomorrow.
Thank you.
Thank you, ma'am. And dear participants, we have one more session in the second half today. I have already announced yesterday also the session.
So Dr. Dimple, can I leave now?
Yes, ma'am. Yes, ma'am.
Okay, okay. Thank you.
The second session will be start from 1:30 as usual. So the session will be taken by Dr. Polas Doctor, the resource person who have taken the last session yesterday. The session is again on scientific writing using LaTeX. So hope you will all join by 1:20 p.m. Thank you all.